Hi, in this brief screencast, we're going to continue working with objects and classes, go over some useful classes that are built into Java, and some more design type things about how do you break down your problem into different classes and what methods should be in which classes, etc. So first off, there's some very helpful Java has hundreds and hundreds of built-in classes, and many of them are very useful. As we've already seen before, when you're concatenating strings, you can use the plus operator to take a string and it concatenate with something and it builds up a new string, and it keeps appending. In this case, we're appending whatever is in ch to the end of what's in str. It works. The problem is it's a very expensive operation because we have to create new strings and then assign them, which throws away the old strings. It's a very expensive operation. So Java provides a string builder class, which is a class. So you can see string builder, we create a variable type string builder, and then we instantiate a new string builder. The string builder class has append methods that allow you to append different things to this the concept of building up this string. So if we append str and then we append ch, and then we can assign str to the builder.toString method, which returns the string representation of the constructed string. So, and string builder is much more efficient than using the concatenation operation, because it doesn't actually build up all these strings and throw them away until we call toString. And it doesn't actually build up all these strings, it builds one string and returns it. So it's a much more efficient tool than using the string concatenation, and I highly recommend that you use string builders. The next useful class, or maybe useful if you have to use the concept of dates, like you want to know what time it is now, so you can use Java util, which is a package, the date class in there, and that's a good way of how you can represent times and dates. There are some bunch of other classes that work with the date class to help you view it as a nice string and all these other things, and doing, how many days is it from here to there and all this kind of calendar stuff. But the date class is sort of the basic of all of them. Another one is the Java util random class. Remember how we were creating dice by calling math.random? Well, there's actually a class called random that allows you to do the random calls, but it has some nice methods, like in this case next int. You supply a parameter of what's the range of the ints you want, and it will actually return an int, so we don't have to do the cast that we did with the math.random. The 6 could be whatever value you want, so that's how you get the values between 0 and 1 minus 6, and so we add 1. So this code is much more readable and easy to use than the casting of math, or 6 times math random plus 1. So this is a nice class that has some very nice features, and it does produce random numbers for you. So those are 3 examples. The string builder class is in Java lang, so you could just call it like you do for strings. The date class and the random class are in the util package, so you'll have to import them into your program. In Java, and I mean with an asterisk, classes are a subclass of object, eventually through the inherited hierarchy. The only class that isn't a subclass of object is object, because you can't be a subclass of yourself. Object itself defines several instance methods that are important for you to override, because object knows very little. I mean, it actually is a very simple class. It provides a toString method which returns a string. Unfortunately, because object doesn't have very much information about things like your class's internal member variables, all it does is return the name of the class and the hash code of the particular instance of your instance. This is not very useful. It doesn't provide you very much information about your class, so you should always override the toString method in all of your classes to provide interesting strings that tell you something about the instance that you're talking about. The other method that object provides is the equals method. Allows you to compare this instance with another object, another instance. Unfortunately, again, at the object level, because it's so simple and it's so at the base of everything, that equals method only compares the references. So for the object, equals method is exactly the same as using the equals operator. So again, if you want your class to compare the contents in your class, you should override the equals method. And I'll give you an example right coming up next. So here we remember our paradise class. We have two ints that represent each die and the role on each die. And so, for example, the toString method could return what the current role is. And so we would actually return a string that says if they're equal, we would say they double whatever the value is, else it's die 1 and die 2, the value 1 and then. So that's a much nicer string than pair of dice and hashtag and some hash number. For example, the equals method, we want to check to see if the two things are equal. So this was referring to the instance we're talking about. If this is the other one, if they point to the same thing, then they're equal. So we return true. If the thing we're passing in is null, then we know it can't be true because we exist and the other one doesn't exist, so that's false. Then we check to see if they have the same class, right? So if this is a pair of dice and the other thing was a string, they're not going to be the same. Then since once we know they're the same class, we can cast the object into a pair of dice, and now we can refer to the other's values and we compare each value of the die, and if they're not the same we return false, and eventually we've compared everything and then we know these two things are the same, even though they don't refer to the same instance necessarily, but die 1 and die 2 are both the same value. So I recommend that you override the toString and the equals op methods in all of your classes so that they actually do the right thing. So how do you do this? You can write your class. First, writing and using classes, first you create the class, so you public class, whatever your name is, you provide your member variables, you then create your constructors, and then in any other of the methods to describe the behavior that you want it to do. Now once you've got your class done, you can now use your class somewhere else. For example, we're going to use our circle info class. We're going to create an array of circle info to hold the information about all these circles. We're going to make it 100 circles. Now that didn't actually create any circle info instances. That just created the array of circle infos which have references to null. So now we need to create each of the individual circle info instances. So we loop over all the things in the array. We call new on it, and we randomly position or create this circle info, and we assign it to the ith. So we do that 100 times, and so we'll have 100 circle info instances stored in our array. And then later on in our program, so now we've initialized our array, later on in our program, we can do things like go to the ith item in the array and then increment its radius and then tell it to draw itself, so we would see it on the screen. So that's how you can use the class that we wrote in the previous step. So the next thing is we want to look at the concept of analysis and design. So we want to modify our program algorithm for creating a program to, instead of just finding out what the tasks are that we're doing, we want to find out what classes we can use to solve the problem, and we want to think in the back of our mind that we want to use, or we want to create these classes that are useful in many situations so that we can reuse them again and again and again, so that we don't keep having to write the same thing again and again and again. Programmers tend to be lazy. We don't like rewriting code all over the time. Let's write the class and then let's use the class all over the place. So we build up our own toolbox of classes that we've developed that help us solve these problems. One thing you should know that you can always subclass an existing class. So if you find a class in Java that is almost what you want to do, but you need to modify it a little bit, you can create a subclass of that class and modify its behavior to do what you needed to do. So I talked about, remember, our programming algorithm is understand the problem, write the boilerplate, and then start working on the tasks to get the job done, and keep refining until you have your solution. Well, the same thing, we analyze the problem. We're gonna, instead of just putting the boilerplate in now, we're gonna figure out what set of classes we need to build. So there's gonna be the boilerplate for the classes, and then each class has some methods that we will use to help solve the problem, and we keep refining this solution. Maybe we need a new class, maybe we need a new method, and finally till we get to the point where we have our design, and then we can start coding the solution, and then after that we would test our solution. So we're just modifying our algorithm slightly. So how do we design classes? Well, the first thing is to take a look at the problem you're trying to solve, and you can look at the nouns in the problem, and that's a good candidate for the classes that you're going to be using. And the verbs in the description of the problem are also good candidates for the methods on the noun. So it's like if you say you can shuffle a deck, well then maybe the shuffle method is the thing that the deck is your class. You should have a shuffle method. And this can lead to an outline of our design that we can then fill in and see if it works. So here's an example out of the text. We're talking about card games. So in typical card games, every player gets a hand of cards, the deck is shuffled, cards are dealt one at a time from the deck and added to the player's hands. In some games, you can remove cards from the hand and add new cards. So what are the nouns in this description? We have game, player, hand, card, deck. Well, we don't have a specific game in mind, so we're not going to worry about game so much. We're not so worried about, so we're going to focus on hand and deck for this example. Some of the verbs: shuffled, dealt, added, removed. So let's take a look at the deck class. So we need a constructor. We need to be able to create a deck instance. Verb is shuffle, so we need to have a method shuffle, which shuffles the deck. We said we have the deal or dealt, so we need to deal a card. So deal a card would return a card from the deck, and since we should know how many cards are left in the deck. So that's an additional thing that wasn't in the verbiage of the description, but it's something that you would think about. Oh, it'd be really nice to know how many cards are left in the deck, and so that's a nice outline for an initial outline or design for our deck class. Now, if we take a look at the hand class, we can remove cards. They said we could remove a card or we can add cards. So we need a constructor. If we want to be helpful or to make it nice, we might want to have a clear method that removes all the cards. You toss your hand in, and then we have add a card. Well, I can take a card and I can add it to the deck, or I can move a card. But what if I want to remove a card at a position in the hand? So like I grab the third card out of your hand, so that might be helpful to have a remove card at a position in the hand. Also, similar, because we have some number of cards in our hand, we may want to know how many there are. And we also all may want to be able to say, I want to get the card at that position. And there's probably some other operations on hand that we would want to do, but this is a nice first design to go through, so you can see that we're going to have to implement these at some point if we're implementing the hand class. But it's a good sort of outline or design of the class that would get us started to being able to solve some, or build programs that play games. And if you want a really good example of this process, read the text. The author has a great example that goes through decks and cards and hands and how to build up a game, the high-low game. And I really recommend that you go through and take a look at that example in the text. I'm not going to go through all that. You can read it for yourself. Thank you for your attention.